Hello, sir. I'm here to explain you about static electricity and its main application. Myself, Tarun KM from Tyagaraja College of Engineering, Madurai. Before we look into these applications, I like to give a little brief introduction about static electricity and its causes. So, what is meant by static electricity? A imbalanced charge present inside a material or on the surface. So, how does this imbalance takes place? All materials are made up of atoms where materials will have same different atoms. So the inside an atom there will be an electron, proton, and neutron. Because of excess of protons, the atom becomes positive, and because of excess of electrons, the atom become negative. Due to this imbalance, there will be an static electricity, which means that atoms will be in static. Only the charges will take transfer. This static electricity is produced due to some external means like electrical force, frictional force, or magnetic force, and etc. Example: in your normal life, you've seen that rubbing of comb in your hair will produce or will attract some pieces of papers when you keep the comb near to the paper. And rubbing of blanket, when you go inside the blanket at night, you find some sparkles coming out of the blanket. This is due to static electricity. So you see here the comb attacks some paper, piece of paper, and this is the rubbing of blanket. How does this imbalance cost or static electricity is produced? It causes due to separation of positive and negative charge in a material. When two materials comes in contact, electron leaves from one material to other, leaving excess positive charge and equal negative charge on the other. This is nothing but like this. When two materials comes in contact, the one gives all its negative electrons to this material and gives all its positive electrons to the other material. So there will be an imbalance in its charge of both metals. So when these materials are separated, they retain charge imbalance, as I said. The charges are exchanged due to weakly bounded electrons and sparsely filled shell when when external parameters are applied. So how does this electrons being transferred from this material to other material? This is due to some weakly bounded electrons or high efficiency attracting atoms, which attracts electrons and becomes negative, which other atoms will be easily tends to give electron and becomes positive. So what are these external parameters? I'll give you three examples. Pressure induced charge separation, that is piezoelectric effect. When you give a pressure or stress on a metal, the charge will be separated as positive and negative. Like if you see in your kitchen, you use your lighter to light the stove. If you give pressure on the top of that lighter, there will be sparkle at the bottom of the lighter. This is due to piezoelectric effect. Heat induced charge separation and charge induced charge separation. This is heat induced charge separation, and this is charge induced charge separation. If you see in this diagram, the first initially the ball is neutral. When a negative when the negative charged electrode or rod is kept near to this rod, the negative charge electron, the negative charge present inside the ball will be repelled by this negative charged rod. Only the positive charge present inside the ball will be attracted. This is nothing but the electrostatic theory. And let me see about applications. There are several applications based on this theory. Xerography is nothing but uh, scanning, printing, all others. Electrostatic precipitator. These are pollution control devices. paint sprayers, powder testing, these are based on the spraying effects. So electrostatic precipitator. So electrostatic plays a major role in controlling air pollution because of its high purification. It is widely used. So we all know that in future the air will be more polluted than now. So to control all this, first we need to control the polluting areas like factories and cars, etc. So to control air pollution in factories, ESP, that is electrostatic precipitators, are used. These are of two types: dry electrostatic precipitator and wet electrostatic precipitator. So let us see about its working. Two sets of electrode, positive and negative. The negative electrodes in form of rods or wires, and positive electrodes are in form of plates. So you see, you can find from this picture, this is electrode of negatively charged, that is a negative electrode, and this is positive electrode plates. Positive and negative electrodes are placed vertically, placed one after the other like this. So this negative electrode wires are connected to the negative terminal, and the positive plates are connected to the positive terminal of the DC source. The positive terminal may be grounded to get more negativity in the negative electrode, and the distance between electrodes and DC voltage are adjusted so that the voltage gradient between the positive plates and the negative electrodes are quite high to ionize the medium. When this dust particle flow comes into this chamber, the dust present inside the air will be ionized due to highly negative electrodes. This will release some free electrons from the electrode wire. So when the dust particle comes inside this free medium, the dust particle will be surrounded by the free electrons present inside the medium. Because of this free electrons, because of this ionization, the dust particles becomes negatively ionized. So it will be get attracted on the positive plates. After becoming neutral, the dust particles gets settled down from the plates. Here, the air present in the medium gets ionized. That is nothing but the air before the particles are, or the dust particles or flu comes inside. There will be a medium air which will be ionized due to ionized by free electrons. Hence there will be, as I explained before, when the flue gases are entered into the container, the dust particles get surrounded by the free electrons in the medium. The negatively charged dust particles are deposited on the positive plates, and the extra electrons are removed from the dust. Then the particle falls due to gravitational forces. The positive plates are also called as collecting plates. This chamber will purify the air about 99%. So this is widely used nowadays in factories, in hospitals. So how we can find the efficiency of the chamber? So by knowing its the particle sizes that we are inletting, we can find the efficiency. Like phi is the efficiency. Phi equal to 1 minus C exit by C inlet, or 1 minus exponential minus WA by Q. Here C inlet is nothing but concentration of particles in the inlet. C outlet is the concentration of particles out. W is migration velocity. Here migration velocity is nothing but the time taken by the dust particles get charged or discharged. This is because when the dust particle gets charged as soon as it gets attracted on the positive plates, Because of this process, the dust removal will be fast and it gets settled down as soon as possible. Because of this, the process will be much faster and it saves time. Here, and A by Q is specific collection. As I told, migration velocity also has its formula. W or BTE equal to NE capital E CC by 3 pi phi d, where n is the number of charges, small e is the number of or the charge of electrons, phi is the viscosity of air at 2933 Kelvin, that is room temperature, or d is the particle diameter. Cc is the Cunningham correction factor, which can be written as Cc equal to 1 plus 2.52 lambda by d for diameter, for the dust diameter is greater than 0.1 micrometer, and the capital E represents electric field inside the conductor. So based on this, we can experimentally find the efficiency of the chamber. So by finding its efficiency, we can easily know that the limits of the chamber of the concentration of air we need to give inlet to get pure air at the out through experimental values. So thank you.